So here we have a regression equation, and we can either plug in the sales volume we want to get, or we can plug in the advertising expenditures and then predict the sales volume. So we can plug in either one. In this case, we know the sales volume we'd like to get, but we do have to be careful because it says that the sales volume and advertising expenditures are in thousands of dollars. So instead of plugging in 225,000 here, we only want to plug in 225, and then we want to solve for this term. So 225, I'm going to subtract 4516 from both sides, 4516, and then I basically have 179.84 equals 0.45 times this. I'm going to divide both sides by 0.45. Divided by 0.45, and this will give me my answer. I do want to remember that I'm in thousands of dollars, so the total answer would be $399,644. This would round down, so it's $399,644, and that's the answer we're given there. Okay, here we need to use the regression equation to calculate the error between the estimated college GPA and the actual college GPA. And then to do the sum of squared errors, we're going to have to take each of those errors, square it, and add it all together. So let's go through that. I'm going to use a spreadsheet to make things a little bit quicker to follow here. All of this, I'll show you what to do in the calculator also. So these are the high school GPAs I've put in there. What we need to do is put each of those into this equation to get the estimated college GPA for each student. So if I were going to do this on a calculator, I'd put in this 3.29 times this number and add this number. And on a spreadsheet, it's very similar. I'm putting in the 3.29, multiplying it by 0.6551, and then adding that 0.67 on the end. Nice thing here is that I can just drag down or click and get all these predicted. The error then is just the difference in between these two, the actual and the predicted. And to be honest, I can't remember which way the formula goes, but I know that it's not going to matter because right here I'm going to square all of these numbers. And so when I do that, any negative is going to just disappear. I'm just going to multiply each number by itself. So if you were doing it in a calculator, you would just type this in times, type it in again. And we'll pull those down there. So these would give us the squared error. For example, this very first one, given the high school GPA that he or she had, using the regression equation, we'd predict they get a 2.82 college GPA, but their actual was a 2.02. So our prediction was about negative 0.8 off, giving us this squared error. And then the last thing we need to do, because it is called the sum of squared errors, it's literally telling us here what the formula is. We're just adding these up, and we should get 1.5450. It says round the answer to 4 decimal places, so we'd have 1.5450. And here we have 1.5451. This would be just a little bit of rounding error along the way. I'm assuming that the tolerance here would allow for that. If you do find yourself running into errors because of that number of decimal places, let me know and I'll try to adjust the tolerance to allow that.